Hi, welcome. In today's video, I want to go ahead and take a chance to talk about Alteryx's In-DB widgets. You will probably see them out there in one of your categories. It's actually called In Database, and we'll talk about what they are more specifically as we use them. But in general, the In-DB widgets give you an alternate way of building a workflow. It's one that I'm not completely happy with just because I'm probably a bit more of a purist, but it does have its place. So what we're going to do is take and replace our puppy registration report and use in-database widgets to do all this work. And we'll be using MySQL to go ahead and do that work with. The reason why people head into the In-DB widgets are for two reasons. And the first one I always want to caution you against, and that is people are very comfortable with the SQL language and how SQL works, and the In-DB widgets, which are all found up here, give you that SQL Select statement feel to it all. But what you're not doing is utilizing the full power of all of the other Alteryx widgets that are available to you to do your work with. And so if the only reason that you're using the In-DB widgets is because you're comfortable with SQL Select statement constructs, I would ask you to go ahead and try to adopt and spend some time researching and working with the Alteryx widgets themselves to get out of the need to use the In-DB widgets. The second reason is again not always my favorite solution, but it's one that I will lean on occasionally, and that is, how do you deal with very large data sets? And when we talk about very large data sets, depending upon the speed of your machine and the speed of your connection to your data source, anything over a couple of million records is very easy to consume within the Alteryx and your machine, again, depending upon your speed. And I'm talking about using this machine that was provided by my employer, which isn't anywhere near as fast as the machine that I provided to myself. Alternately, you have to keep in mind that if you're productionalizing all of this work, you need to look into getting an Alteryx server, and then you have 3 or 4 times the speed and power depending upon its connectivity in your workflows as well, which extends out the size of the tables that you will need to work with. But if you have a very robust data warehouse out there and you have hundreds of millions of records in a lot of your base tables, you can't bring 100 million records down to your local machine and then begin to trudge your way through it. You really need to limit the amount of data that you're bringing into the Alteryx workflow. And there's one way that you can do that with the In-DB structures. And then finally, the third part of this exercise, I'll be talking about how to do what I call heavy lifting within the standard input data widget. So what our attempt is to go ahead and repeat this exercise so that we can do all this work up on the RDBMS server, which in my case is MySQL. Oh, and just as long as I want to mention it, another reason why I really don't like everybody falling into the standard of using In-DB widgets is what you're writing will not be transportable from one RDBMS to another if you're using the In-DB widgets. But if you are using the standard or native Alteryx widgets, it's portable because those widgets are pretty agnostic as far as what source they're looking at. That being said, let's get this started. Now, a couple of things that you want to do before working is that you may have created a ODBC connection or some other type of connection to your RDBMS, But if you're going to be using your In-DB connections, you need to create your In-DB widgets. You need to create a new connection that is specifically for In-DB. And we'll take a look at that very quickly. So if I come over here and start with my in database, the first thing I want to do is connect In-DB. This does more than connect you. This also goes ahead and opens up the table so that you can begin processing of your workflow and get data flowing through it. When I click on this, you see that it actually comes up with a different drop-down list because it's looking for a database connection. In my case, mine is a MySQL, and I have created this In-DB connection. But let's take a look at what had to happen to accomplish that. And that is within the Manage In-DB connections. If I want to create a new one, I would click on MySQL and then click on New, and then I would give it a name. And in this case, though, we really don't need to do new because I already have one. But again, MySQL New, give it a name. Well, here in my drop down, I have an existing one, and I happen to do the same thing. MySQL New, MySQL In-DB connection. I had to tell it what connection to use, and that is where I went into and was able to choose from my already established ODBC connection to the MySQL database. If you're using this against another database, you should use that same connection at this point. It will go ahead and populate the connection string for me, and then we come down to our options. You notice there are two tabs here, read and write. I like to choose the none. That causes a problem with MySQL, just in case you're running into issues using In-DB with MySQL. I'm going to show you what that error looks like, and then we'll fix it. So my style that I normally like, that I really rely upon, is the none. Otherwise, it will put everything in quotes. I also then need to choose how this same connection will write. But in this case, I want to go ahead and use the same as the read driver. You really can't create a second connection to the database with this. It gets to be a little tricky. Recommend that you use the same as the read driver. And again, we'll go with the none just to show you how I normally like to use it. And then we'll go ahead and correct things when we see the errors there. I go ahead and cancel this because that is just creating it. Here is my connection. Oh, that reminds me, we actually want to go ahead and modify that. Let's manage this guy very quickly. Turn this quoted off. Turn this quoted off. The reason I want to have that error come up is because I want you to see how you have to go about debugging something that's not working. So here we want to use a table. In this case, what we want to use is my Daisy Hill date dimension, rather than the other one, the other workflow where we created a series of dates. We're just going to go ahead and create them from the date dimension. Test that query out. It shouldn't work. I got an extra quote in there. So that's great. If we want to go ahead and look at this, we can't take a quick look at it because, again, this is simply something that is creating a piece of SQL. Everything that I'm doing here is going to result in a SQL Select statement and all of its clauses in order to execute the data blending and manipulation that I need. So I can't really look at what's going on there. So we want to go ahead and select off just simply one column. We're going to put a select in DB. It does to a degree the same thing, but not quite. Because if you notice, all you can do is rename the fields. You can't change their data types. All we really want in here is the calendar date. So we'll select the select all, choose calendar date. We only want a specific range of values. Remember that we're looking at just the first quarter of 2021 for this report. And we do that with a filter in DB. So we want the calendar date to be between two values. And again, as you notice, you don't have that option up here. So this is where you begin now to fall into the understanding of how does your RDBMS work? What is available to you? Not what Alteryx can do, but what your RDBMS can do. Well, I know that we do happen to have a between function within the RDMS. And I know that if I give dates as a format of 0101, a year month, this is how that command would look, what that clause would look as part of the select statement within the MySQL database if I was writing this. This is not what you would do within Alteryx perchance, but this is what you would do if you're writing the SQL. And again, if you're using something other than MySQL, you got to make sure that you put this date in the right format for that RDBMS. Once we've done that, we'll modify our annotation to simply say between. And then at this point in time, we would like to see what the answer looks like to a degree. We do have a browse in-DB. Browse in-DB will just simply execute this and to give us a sample what the data looks like. Run that. And we see it gives us our dates that we expected to see from this query. To continue working through this, it'd be nice to see what that query looks like, just so that you'll believe me that it is indeed running a query. We have this dynamic output in DB. What this does is this will return us information about the query at that point in time. In this case, all that we want to see is the query itself. If you notice that all of the connections in here are blue, which indicate that they are all running in DB. This widget has a blue in and a green out, which means that we're returning back to the native Alteryx widgets. It will return as the SQL at that point in time. We run this. And you can see down here is the select statement that is executed. If you notice, one of the things I am not all that impressed with, and that is that it does embedding of all your widgets. Every time you use a widget, it creates a select statement just for that piece of the widget. So consequently, what it's doing is building you subqueries for every one of these widgets that you're doing. So if you have 10 widgets here, you will probably have 10 subqueries as it processes through that piece of data. This is where it gets to be a bit messy and a bit hard to move forward. We'll leave that here just for reference purposes, and we'll continue on with our workflow. What we need is to bring in a second table. That would be our puppy trick table. Again, we drop in a connect DB. Choose our connection. Make our life easier. We'll just run over the tables here and get the puppy trick registration fact table. And what we need to do is to join these two together so that we just get the records that are for the first quarter of 2021. We do that with a join in DB. Again, connect both sides of this. You'll notice a lot less functionality. We want to join on the calendar date being equal to the registration date. And now we actually go back, and rather than use the Alteryx style of the join, we're going to be using the database style of the join, because you notice there's only one output here. And so again, you have to know how that SQL is going to be running and what the terminology is for the SQL Select statement on your RDBMS. In this case, we want a left outer join. Take a look at the data coming out there. We'll drop in our browse In-DB, give this a run. And you see that we get an error saying that every table needs to have its own alias. It's the best we can do. This is where we need now to say, gosh, I wonder what might have happened here. Remember, we saved this up here. Let's go ahead and drag this down here. Let's figure out what went wrong at this point. So let's run this one more time. While this one will error out, it does indeed give us the SQL down here. You notice that it truncates it, makes it a bit harder to see since it is being truncated. So we have this query that looks pretty good at first glance, but we're not sure why it's not working right. And this is where debugging comes into play. Interestingly enough, so that we can go ahead and save this output into a flat file so that we can actually see what the data looks like. I'll paste my handy dandy little CSV generator. This is nice because it will indeed capture all of the field for us. Put this into a spreadsheet. It won't necessarily capture all this data either. It gets a bit tough with very large files. So now if we run this, we take a look at the CSV file that came out, and we can see from the CSV file that here's our query. Again, it's just really strung out. It looks pretty good at first glance. I mean, keep in mind you have all of these subqueries in here. You're not sure exactly where it's breaking down. So what we're going to do is to copy this out, go into MySQL Workbench, connect to my Amazon Web Services RDS MySQL database. Let's go ahead and type in that query. As you can see, this doesn't do much either. Typically when I look at these, what I begin to do is to go across here and break these up into smaller pieces. So here is one query and then another subquery down here. You see how these goes. We're actually going to stop here because, nicely enough, if you're familiar with using any of the RDBMS querying tools with MySQL Workbench, it's gone ahead and highlighted all the reserved words for us. And that is sort of where we notice that things went south, because these are reserved words that cannot be used as an alias name. And so the default that Alteryx is doing is in this query subquery here. This is where it's the right side. It actually named it right. That being a reserved word, we're in trouble. We need to get rid of that reserved word. Took me a minute when I was running this to figure out where this came from, but I very quickly latched on and understood the mistake that I had made, which really wasn't a mistake. It's just a case of using a different RDBMS for my In-DBs than I had been using in the past and falling back on old methodologies. But I want to give you a flavor of how you would have to go through debugging if you get a SQL error. This one was caused pretty easily because what happened is, remember at the beginning, I don't like putting double quotes around all of my object names. I'm going to come down here into Advanced Options, Manage In-DB Connections, go to the MySQL, go to the existing MySQL connection. We're going to go ahead and edit these to be quoted, which it just popped back into the default, which makes it a bit confusing when you're doing this. It really is trying to tell you it wants to do that. We're going to apply that, click OK. Let's give this one more quick run through. Tells me that I already have this file open, which is absolutely true because I left it sitting here open. So let's close it out. We really don't need to worry about this. But now we see that it has indeed gone through and completed my joins for me. Interestingly enough, we didn't actually get the data that we expected. So let's take a look and figure out where we went wrong in here. Wrong dates were put in here. It's always fun to try to debug these live. Connected it to the false side here by accident is where we went wrong. Awesomeness. We don't need to be doing this anymore. Let's just go ahead and drop a browse onto this. Sorry for the debugging on the fly. Should look a little bit better coming through now. So here we go ahead and we have data coming out. Continuing through with this, now we want to continue with our development of the In-DB. We want to go ahead and do our select so that we can get just the columns that we need for this exercise. Drop this onto here. We want to deselect all of them because all that we really need is calendar date, because remember this is the left join. That would be the registration date or previous work, and then we have the fact count here. Still staying within our In-DB, we have a summarize. Again, please take notice that as we do this, while the overall structure of this looks the same, you notice there's a whole lot fewer options to choose from because this is what the RDBMS will allow us to do. Just the basic RDBMS summarize or group by. Give us this is name, registration, fact, count. Again, running through this, and continue to browse the data. We can see that we do indeed have this empty record here for the 11th, as we did before. We want to replace that null with a 0. So we'll drop in the formula In-DB. And remember, again, I hate to keep reminding you of this, but what we're having here is utilizing the functions that are available on the RDBMS. We also know that we can't create a field. We can simply just, actually we can create a field. I don't use this very often. We can create a field just by typing in its name. I sort of thought it was there. Scary when I saw it not. Let's go ahead and delete that one off. Cool. We want to deal with the registration count. Again, you can't change the data type. Couldn't change the data type here either. So we have to live with this double at this point in time. The expression we want to use is a SQL expression. And we want to go ahead and set that equal to the coalesce of registration. Let's go ahead and insert our field just to show you how that works. We want to coalesce, which is the null value function, which would be nice to have inside of Alteryx, but they don't have this nice function. You have to use the if then else. In this case, things are just a little bit better if you know about the coalesce function. Coalesce says to take the first not null value. So if registration count is null, it'll give it a value of 0. Running this one more time. Move this over here, and you can see now that that's null has been replaced with a 0. So we're ready to go with our report. To do that, we need to bring the data down to our native Alteryx workflow. We do this with the data stream out. So this will bring the data out. And just to save time and effort, I'm going to go ahead and copy off the report that we ran before. Paste it here, because now you notice we've gone from the blue of In-DB to the green of native local. I can attach our normal reporting to this. Since everything was named the same, this will flow from the puppy trick registration process. We can see now we have our bar chart, which has the gaps for where the nulls or non-existing registration days were, which is what we wanted to see. So now we have successfully created an In-DB where all of this work is being done on the database. None of it is being done locally. Keep in mind that we had to go through and think about how the MySQL RDBMS processes the select statement, and then create all of those widgets along the way. For reference point, this is doing it within native Alteryx workflow. This is the In-DB workflow. I have always found that any workflow that you're doing in DB is going to have more widgets, more steps, and more operations. And you'll be utilizing the widgets differently, even if they have sort of the same name, because again, they are RDBMS specific. The next step of this video will be to talk about where I typically use an In-DB structure occasionally, and also how I can replace that with the native input data widget as well. So let's go ahead and get ready and start another new workflow to where we will do this slightly differently. So let's open up a new workflow. So again, the primary reason why we want to do this is that there's too much data in the database for us to reasonably bring down to our local workflow. I call this the heavy lifting. Let's copy out the heavy lifting piece of this, and we'll talk about it once we get it into here. Part of the reason why the In-DB structures are there is also because people are a little bit uncomfortable with creating SQL Select statements. One of the things that you can do with data such as this is to create views that people can then use, and then you have issues of documentation and maintenance, etc. People like to avoid that as well. But that being said, what we're going to utilize our In-DB structures to do in this case, let's go ahead and run this, is that we will go ahead and identify our two tables that we want to join. We will do our select to limit the amount of data coming through the process. We will go ahead and do our filter, and again, knowing that this is indeed beginning to learn this SQL language. If you're not familiar with it or comfortable with it, this is not going to help you. We then do our join. We finally select off just the items that we want, do a quick rename. So what we have done at this point in time is created that smaller data set that we want to bring down and do further processing with. Again, I call this the heavy lifting. So then all that we want to do with this is to finish it out with this type of work, which is the summarization and the processing into it. We can copy this out as well. Paste it onto the end. The problem that we have obviously in us is that we cannot connect the blue connector to the green connector. So therefore we must move the data from the RDBMS, which actually will force the execution of the SQL that's built to that point. We go to our in-database structures. We do our data stream out. Drop it down here. You can see that the data stream out has blue on one side, green on the other side. So it quite naturally drops right in the middle there. Let's go ahead and move this to the side. There we go. Get it to be a little bit prettier. Drag it over so you can see all the finishing of it. Since with this select statement here, we have done most of the cleanup work that we want to do, but given the fact that we would also like to make sure that's just a date coming through there, which we could not do in the in-database select, we'll go ahead and go back to our preparations in our native widgets, put a select in here. Gives us the opportunity to change this registration date from a date time to a date. Makes our report look a little bit cleaner when we run it. Running this now, it'll go ahead and process that, move the data down locally, run through the summation, fix the data, and ultimately generate our report. So this is a great way for someone that has a large set of data that's not completely comfortable with a SQL Select statement. Being able to go through this and utilize the In-DB structures to create that heavy lifting SQL for you, move that data down, and finish your data analysis preparation and blending locally. Taking the next step in this is to begin to understand how to create some of your basic SQL Select statements, which gives us two new skills to work with. One is the ability to get out of using the In-DBs, as well as a knowledge of how to do some analytics in the RDBMS to prove whether or not your workflows are working properly. Because I am asked to ask some of the people that I work with, how do you verify that your workflow is correct once you're done with it? And they're like, well, we're not sure. I said, well, that's where you need to go back to the RDBMS, be able to create some basic queries to see if you're at least in the ballpark for what your solution is giving you. So part of what I've taught in the past and continue to teach is the SQL Select statement language, so that people can become more comfortable with utilizing their RDBMS. And so that sort of brings us to the third way of solving this problem of too much data in the data warehouse to bring down to our local machine and then sort our way through the data. And this is the typical heavy lifting that I use. It starts with understanding a little bit about how this piece of SQL here is going to work, and we showed in the previous parts of this video how you can see that SQL, but it's pretty messy SQL to go through. And so what I will do is clean that up and slowly teach people how to write basic SQL. And so this is actually the SQL that we would want to use to do this heavy lifting for this problem. And ultimately, if you look at the SQL that Alteryx generates, this is what that SQL does. Nothing more, nothing less. It just does it in a much more stepwise fashion so it can go from widget to widget. So I select my three columns that we were using, and we do it from our primary table. We left join it to our second table, identifying how we join those two tables together. We put our where clause in here that we would use directly into our In-DB widgets. We can then execute this. Execute it now. It's very quick, and it gives us the data that we want: the calendar date, the registration date, and the fact count. And in fact, we really don't want the registration date now that I look at this. We just really want the calendar date and the fact count. Because in my select, I do not have to have the attributes that I do my comparison with, but I do need those attributes in my In-DB queries. Run this one more time. We see here it is. This has a different name. We could use an alias if you're familiar with SQL to change this name, but we just sort of want to plug this into our existing workflow. So what I do is, I know this query works. I will copy it out of my SQL editor, drag that out of the way. We're going to go to a new workflow again, and we're just going to go ahead and drop my input data into here. Connect it up to the MySQL database. In the SQL editor, I am just going to paste that query exactly as it executed within my SQL editor. Happens occasionally. Goes to sleep, I think. No errors. I click OK. Cache the data if I want to. Quote, it really doesn't matter since it is going to go ahead and use my SQL directly as is. I do want to see the % complete just in case it is a large data set. It's nice to see how long it runs up on the RDBMS server. One of the positive outcomes of this is that your data, once the query is finished running and the data is being fed locally, it's going to do so in a buffered manner. So as those records are returned within the query itself, they're coming down. So you actually get a little bit better performance out of Alteryx doing this. We can hit the refresh to execute that, or we can just run it. This is the data we wanted to see. This is exactly the same as came out of all of these widgets. So now what I can do, which is one of my favorite things, which is copy and paste, simply take the end of this, copy it, paste it, connect it up, rename this as registration date, change it to a date, keep in mind that if we move all these missing fields as a simple change down here in the options we have remove, forget missing fields. So this now looks pretty straight and clean. Everything else hooks up. Run this, and we see the report comes out the same. Makes a much more cleaner workflow. Also means that I can now go and utilize this embedded SQL to make sure that I tested out what was occurring and I'm happy with what I'm using. And again, it takes some knowledge of writing SQL, but you can embed that SQL once you're happy with it to do the heavy lifting right into this workflow. That query will run on the RDBMS server and then just return the records to us. So it makes a very efficient, very controllable, very precise workflow. It's my choice for when I'm doing heavy lifting. If you like this video, please comment, subscribe to my channel. Let me know of any additional things you would like to see as I continue to work through all of the different workflows and videos I've created in the past and make them available to you here on my channel. Thanks. Have a great day.